The remainder theorem, what's on the agenda today, we're going to talk about after a little introduction to refresh your memory about division. What we're talking about are things like this: 21 divided by 5. Now, you might know how to do that already, but this will help us guide our way through more complicated questions. The answer is 4 with a remainder of 1. Now, another way we could have written this, of course, is we could have said 21 divided by 5. And another way we could have written it, which is very useful to us, which goes back to elementary school, and that is to say, how do we check our work? Well, 21 divided by 5 goes in 4 times with the remainder of 1. So we check our work by saying, well then, 4 times 5 plus the remainder should equal 21. And indeed it does. Now, if we use that kind of logic for more complicated examples, which you'll see in a moment, thinking back to this will help guide you as to what gets multiplied with what. So let me show you what I'm talking about. We take 1, and first of all, I'm going to do the long division to show you what the answer is. Suppose we were going to take x minus 2 and divide that into x squared plus 5x minus 2. I want to see what is the answer there when we do the long division. Now, you may have forgotten how to do this kind of long division, so I'm just going to refresh your memory. We focus on the x out front, so the divisor here, we focus on the x. We say, well, x times what makes x squared? X times x. So x times x is x squared. X times negative 2 is minus 2x. Then we put brackets around this stuff and subtract. So it's just like long division with numbers. X squared minus x squared, that's gone. 5x minus negative 2x, so 5x plus 2x, 7x. We bring down the minus 2. And again, we look at the x and ask ourselves, x times what makes 7x? Positive 7. So 7 times x, 7x. And 7 times negative 2 is negative 14. We put brackets around these guys and subtract. 7x minus 7x is gone. Negative 2 minus negative 14, so double negative. So negative 2 plus 14 is 12. And that's where we stop. That's our remainder. So what we now have is we know the following. And I'm going to rewrite this. So we'll just kind of take a little note here. I'll write it up here, and then I can erase my work. I'd like to keep that written there. Show you another way we can write it. We know that this dividing into this goes this many times with a remainder of 12. So it's not that different from when we had the example with the 21 divided by 5. Maybe I'll even write that again to really illustrate my point. 5 into 21 is 4 with a remainder of 1. And then we rewrote this guy a different way, and that was to say, well, 4 times 5 plus the remainder should equal the 21. Now watch what happens when I rewrite this. I can write this as x plus 7 times the x minus 2 plus my remainder, which is 12, must equal the thing that I'm dividing into. So this polynomial, x squared plus 5x minus 2. Now that's a very important division statement, writing it this way. And it's what really lends itself to what will become the remainder theorem. So now we're going to look at some very interesting observations here. This I'm going to remove. So here's our, actually I'll get rid of this. So here's our division statement. I'll write it at the top here. We've got x plus 7 times x minus 2 plus our remainder ends up equaling what we were dividing into. X squared plus 5x minus 2. Okay, so we got it rewritten. Now here's the observation that I'm interested in making. Here we have the left side and the right side. These things are equal. This is what we normally think of as our polynomial, or p of x. And this is just a different form of expressing that polynomial. And in this form, an interesting thing happens. Suppose I chose a value that would turn this stuff into 0. In other words, I'm going to select x equals 2. Okay? Now, why is that such a good choice? Well, if I put a 2 in here, I'm going to get 2 plus 7 is 9. But then I'm going to get times 2 minus 2. 2 minus 2 is 0. So what I'm going to end up with is 9 times 0 plus 12. And it equals all this stuff over here, which I guess we'll just put in the 2 here as well. Since x equals 2, we're going to substitute that in on the right. 2 squared plus 5 times 2 minus 2. And of course, what's going to happen is that's 0 plus 12, or 12. And over here we get 4 plus 10 minus 2, which also equals 12. The important thing to note here is what we have left over here is the remainder. So in other words, what happened here was the following. We will start looking at the question again through new eyes. We had x squared plus 5x minus 2 divided by x minus 2. Now we worked out the answer and in that long process found the remainder. But here's a very quick way to find the remainder. We just realized if we choose a substitution for x of x equals 2 and plug that into this thing here, x squared plus 5x minus 2, that turned out to be the remainder. Okay? And the reason it works is because what it's going to do is you're going to get, of course, some kind of answer if you did your long division, an answer and a remainder. I'll just say REM there. And so if we wanted to, we could look at this and say, wow, this times the answer plus the remainder, that times the answer plus the remainder equals this polynomial. And by choosing an x value of 2, this turns to 0, wipes this out, and you're left with the remainder equals x squared plus 5x minus 2. And we know x is 2, so we're going to calculate that by putting the 2 in for x. It's a handy-dandy way of finding the remainder without doing all the long division. Let me just do another example. Let's take the same trinomial, and this time I say to you, oh, let's figure out what it would be if I divided it by x minus 5. Instead of working out the answer through long division, all we want to do is figure out what the remainder is. So the process is you make the choice to turn this divisor here into 0. And that choice would mean x is 5. Now we take that value and we substitute it into the polynomial, which is getting divided up. So we're going to go 5 squared plus 5 times 5 minus 2. Well, I work out these numbers. I get 25 plus 25 is 50 minus 2. There's my remainder. It's 48 without doing all that long work. It's a very quick and neat way. Okay, let me just summarize what the remainder theorem actually says in a general kind of way. It says if you have some kind of a polynomial and you're going to divide that up by some kind of divisor, you're going to get some kind of an answer and a remainder. Okay? We know that happens. Sometimes the remainder turns out to be 0. Sometimes it isn't. And another way, what's called the division statement of writing this, is to say, well, divisor times our answer plus remainder equals the polynomial that got all divided up. So what the remainder theorem says is, if we want to just find the remainder, let's make all this disappear. And the choice there would be, if we know what the divisor is, then pick an x value that makes the divisor turn to 0. So by making this equal to 0, all that's left is the remainder. We use the same choice for x over in the polynomial, and boom, you've got your remainder. So that's essentially what it says. Let's do one last example. See it in action. Okay. We've got 2x cubed minus 5x plus 3. We want to divide that by 2x plus 1. And by the way, I could have written that like this. Say or. I could have wrote it like this if I wanted to. Take that guy and divide it up by this guy. It says the same thing. We just want to know what the remainder is. So here's what we're going to do. We're going to say, well, what value of x turns that to 0? So the first thing I need to do is decide, how do I turn that to 0? Well, we'll solve for x here. Bring the 1 over. Divide by 2. So I got negative 1/2. That's the correct choice for x into this polynomial. And whatever comes out in the wash is the remainder. So I'm going to give myself a little extra room here. So we take this guy here, and we're going to plug in an x value of negative 1/2. So here we go. Negative 1/2 cubed minus 5 times negative 1/2 plus 3. It's got a little bit of number crunching to do. Negative 1/2 cubed would be negative 1/8. This would become positive 5/2 plus 3. I can divide the 2 into the 8, so I have negative 1/4 plus 5/2 plus 3. To put these all together, I'm going to create 3 fractions with a common denominator of 4. And then I can combine them all together over 4. We would have negative 1 plus 10 plus 12. Whoops. So we end up with, that's going to be 9. 9 and 12 is 21/4. That's the remainder, using the remainder theorem. So, with that, I'm going to stop.